Hey Physics 6, let's look at problem 4 from the Newton's second law worksheet. In problem 4, it was similar to problem 3. You're pulling a box with a rope, except this time you're pulling it at an angle. So a sketch would look something like this. There's the ground. Here's the box. Here you are pulling with the rope. It's now at an angle, 15 degrees. The free body diagram, remember we look at the object of interest. The object of interest is the box. It's not the ground, it's not the rope, it's not you. We place that object of interest at the center of a coordinate system. We'll use the usual X, Y, horizontal, vertical coordinate system. Here's our object of interest, the box. Now the forces involved are the same 3 forces as in problem 3. There's gravity. There's the gravity force of the earth on the box. There's the normal force. Normal force of the ground on the box. And then there's the tension force from the rope. This time the tension force is at an angle. There's our 15-degree angle. So that tension force has X and Y components. If that's tension, the magnitude, and there's the angle, 15 degrees, then the Y component gets sine, it's opposite in that triangle, and the X component gets cosine because it's adjacent to the 15-degree angle. So our free body diagram is complete. Let's look at the Newton's second law equations. First we'll look at the Y direction. Sum of the forces in Y equals MAY. Using some common sense, you can tell that the acceleration on Y is 0. The box isn't moving up or down. And we've got 3 forces in the Y direction now. You got the normal force, that's going up. You've got this upward Y component of tension, and you've got the gravity force. So if you do a little algebra, you can see that the normal force equals gravity minus tension force. Or mg. Get out of there. mg minus t sine 15 degrees. If you plug in these numbers, that mass was 120 kilograms, tension force was 350 kilograms. That would give you a tension force, or a normal force equal to 1,085 newtons. Remember, M was 120, T was 350. Now if we look at Newton's second law in the x direction, sum of the forces in x equals m ax. And as before in problem 3, we just have one force in the x direction. It is this x component of the tension. So we just have Tx equals max, and ax equals Tx, which was T cosine 15 over m. Putting in the numbers, that gives you 2.82 meters per second squared. So if you compare these results with problem 3, notice that this normal force is less than the normal force from problem 3, and the acceleration is less than the acceleration from problem 3. The reason for that is because since you're pulling at an angle, you are decreasing the normal force because you're kind of lifting the box above the ground a little bit. So the ground doesn't have to supply as much normal force. And also by pulling at this angle, you're decreasing the amount of horizontal pull, so there's less horizontal force in the x direction, and the box doesn't accelerate as much as it did before.